Hi guys! So today we are tackling lesson 9 and we're going to start with multiplying with tens. So we're looking at place value for multiplication, multiplying by bigger numbers, and especially we're also considering some of the traits of multiplication that we talked about last time. So we talked about the commutative property, how we can flip-flop the order of our factors to still get the same product, still get the same answer. We also talked about our associative property, how we can group numbers in any way that we like with multiplication and still get the same outcome. And we also talked about the distributive property, how we can also break apart numbers to make them easier as a way and still get the same product as well. And we've already kind of been working with that. So when we think about multiplying by 7 as breaking 7 apart into 5 and 2 or 3 and 4, that's the distributive property. So using smaller numbers that are easier to work with when we are using multiplication. So today we're going to be looking at using the distributive property when we are multiplying with greater place values, and specifically we're going to start with tens. So go ahead and we're going to start on page 216 today. So go ahead and turn in your packets to page 216, and you'll see at the top that it says a sports store orders 4 boxes of baseball caps, and each box has 40 caps. How many baseball caps does the store order? So they have a couple of different ways that you can think about it. You can think about it with a picture. Here they are using our base 10 blocks or base 10 drawings to go ahead and look at it. So you can think of, in your picture, I'm actually going to show it in a different way. They have it with the base 10 drawings, but I'm going to show it just as, here we have a box of baseball caps. I know it doesn't look like a box, but remember, my math pictures are just going to be really simple. So this is my box of baseball caps, and each cap has 10. Nope, sorry. Each cap has 40. That's an easy one to correct. Baseball caps in it. So I have 4 boxes, and each box has 40 in it, right? So in your packet, the problem is showing it as we have 4 tens by using our base 10 blocks. I've just shown it as writing in 40. So I have 40 4 times, right? I have 40 in 1, 2, 3, 4 boxes. So we can think of it as we have 4 groups of, so what I'm going to do first is I'm going to go ahead and break these apart and think of it that I have 4 boxes or 4 groups. Try that again. 4 groups of 4 tens, right? Because we know that 4 tens together would equal 40. So this would be like saying that I have 10, 20, 30, 40. I have 4 tens. So already right there, we've made the problem simpler, right? I can think of it as 4 groups of 4 tens. I could think of it as 4 times 4, and then make sure that that's the number of tens. So 4 times 4 I know is 16, but because I'm multiplying 4 tens, it's actually 16 tens. So I know that 10 tens, 10 times 10 is going to be 100. If I add 6 more tens, that's like adding 60, or making it 160. Now, the nice thing with working with tens is that there's an even faster way to think about it. I could think about 16 tens as 16 with a 0 on the end. So I can think of 160 as being 16 tens, or 16 plus a 0 at the end for that place value, to show that it's 16 tens and not just 16. Okay, so that's one way that we can think about the problem, and breaking it up into smaller, easier to work with problems. Below that, it also says model it. You can also use factors and grouping to multiply with tens. So we did some of that. We multiplied 4 by 4 tens. But another way that we could break up our numbers is I'm going to go ahead and write out our equation. We have 4 times 40, right? That's really what we're talking about. 4 tens would be the same as 40. So if I wrote it out as my numbers, I could write it as the equation 4 times 40. But I see that 40 and I go, ooh, I don't like that. That's too big. I want to simplify the problem and make it easier. So I'm going to think about my 40 as 4 times 10, right? Or 4 tens. So I'm going to think about, and then if I rewrite it, I have 4 times 4 times 10. So I've used my distributive property, and I've taken that 40 and I've divided it into some smaller pieces so that I say, oh, I know 4s and I know 10s. That's a lot easier to work with. I'm more comfortable with that now. So I'm just going to go ahead and erase what I had previously, because now I'm dealing with my new equation, 4 times 4 times 10. So I broke apart the 40 into 4 times 10, and so now I have a new equation. Now remember, I'm also going to use another property. I'm going to use my associative property and group them together any way that I like. So I was thinking of it as 4 times 4 times 10, but now I'm going to change my parentheses to this 4 times 4 instead. And then I'm going to multiply by 10 afterwards. So 4 times 4, I know my 4s. I know that they're double doubles. So 4 2 times would be 8. Double that again and I get 16. So now I have 16 times 10. Now, one of the cool things about tens is not only, I'm going to write it up here just so I have a little bit more room. One of the cool things about tens, working with tens, is that you can skip count, right? So we could skip count 16 times, saying 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160. We could do that. But when I start getting into higher numbers, I'm going to use the same property or the same principle that I did previously of thinking about it as 16 and 10 I'm going to think about it as 16 times 1. Remember, any number times 1 is going to be itself. So that would give me 16. But then I'm dealing with tens, so I'm going to add that 0 to the end, making it 160. Now I'm just going to go ahead and show that with a couple of different options. So I'm going to erase this, and I'm going to show you that this works every time you multiply by 10. So let's go ahead and I have 28, and I'm going to multiply it by 10. So I'm really going to think about it as I'm multiplying 28 times 1, but it's 110, so I'm going to add a 0 at the end, making it 280. Okay? Same thing. Let's do one more. Let's do 12 times 10. Okay, so 12 times 1 would be 12. Add 1 0 to the end, and it becomes 120. And we can test that by thinking, okay, I'm going to break up 12 into 10 and 2. 10 times 10 is 100. 10 times 2 is 20. 100 plus 20, we still get 120. Now what really is cool about this is this will work for any multiple of 10. So anytime we multiply by 10 or hundreds or thousands, we can use this place value trick that I just showed you with the zeros. So let's say, for example, we want to do 12 times 100 now. I'm still going to say 12 times 1 is 12. I have 2 zeros. So my answer is also going to have 2 zeros. So 12 times 100 is 1200. or 1,200. Don't worry too much about that. We're not going to be getting into upper place values yet, but next year when you're in the 4th grade, it will come in handy to already kind of have a head start on that. All right, let's get back to our lesson though. So go ahead and turn now to we were on page 216. Go ahead and turn now to page 217, and we're going to answer some of the questions. So it says below are 3 equal multiplication expressions from the previous page. They have 4 times 40 is one expression. We also have 4 times 4 times 10 is another one. And then we also have 16 times 10. So those are all written up at the top before any of the problems. So now let's take a look at the problems. Number 1 says you can break apart 16 into 10 plus another number. Write the number in the blank. So they have it as 16. So this is number 1. 16 times 10 is the same as thinking of 10 plus some number times 10, right? So we've basically taken our 16 and broken it apart into 10 plus, we would put in 6, right? Because 6 plus 10 would make it the 16. But again, we're using that distributive property. We're breaking apart our numbers into numbers that are easier to work with. So now number 2 says you can multiply 10 by both numbers in the parentheses in problem 1. So I'm going to take my 10 and multiply it by the 10. So I have 10 times 10 as one fact. And then I'm going to multiply it by the other number. I have 10 times 6. And then I'm going to add those two together, right? So I'm going to get my 2 answers, and then I'm going to add them together. So let's find what that would be. So number 3 says write the products in the blanks. So that's what I'm going to do. So for the first one, they actually wrote it the other way. 6 times 10. So you would fill in 10 times 10 and 6 times 10 because we've taken our 10 plus 6 and we're multiplying both of those by the 10. Now I'm going to find my products for each set. I'm going to have 10 times 10 I know is 100. 6 times 10 is 60. When I add those two together, number 4 says add the products and write the sum in the blank. 100 plus 60 would get me a total of 160. So we basically did 1, 2, 3, and 4. All in one fell swoop. All right. So now what I'm going to have you do is go ahead, first of all, if that went too fast, if you're like, what, Teacher Jess, I totally don't understand, what I want you to do is pause the video, rewind it a little bit to the beginning part of this problem, and rewatch it, watch it again, so that you can see the steps again. First, we took 16, we broke it into 10 and 6. We're still multiplying it by 10. So then the second part, I just rewrote it in a different way, 10 times 10 and 6 times 10 from my part here. 10 times 10 gets me 100, 6 times 10 gets me 60. I'm going to add those together to get my final product of 160. Okay, so again, if that doesn't make sense, if that went too fast, go back and rewatch it because sometimes the second viewing is all you need to go ahead and access that information. All right, we're going to go ahead and move on to page 218, and I'm going to have you do the next 3 problems on your own. So pause the video, do numbers 8, 9, and 10, and then we'll look at them all together when you're done. All right, now that you've completed numbers 8, 9, and 10 on your own, let's take a look. Number 8 says we're going to multiply 60 times 8, and they want you to show your work. So anytime they say show your work, it's like giving me a window into your brain. How are you thinking about the problem? So your work may look different from my work, but I'm going to give you a window into my brain to think about how I've been approaching this problem, and then you can see if it matches your thinking. If we get the same answer, then you just might have a different approach, and that's totally okay. If you get a different answer, you might want to look back and see which was the part that that was different, that got you a different answer. So I'm going to go ahead and think about this. I'm going to break this apart into thinking of 60 as 6 times 10. So now I'm going to rewrite my problem, but instead of writing it as 60 times 8, I'm going to write it as 6 times 10 times 8. But I still don't really like that because I really want my last step to be multiplying by 10 because I know how easy it is. I know I can just go ahead and add a 0 at the end. So I'm actually going to switch these two numbers around, and I can do that because of the commutative property. And I'm actually going to say, now I'm writing it as 6 times 8 times 10. Now I'm going to group my 6 times 8 together first. And I'm going to, and notice that as I'm doing this, I'm writing down all of the steps. So the one step that I didn't show was that I erased and flip-flopped mine. You didn't have to erase. You can go ahead and write both expressions. But this is how I'm writing out all of my steps. So this is that window into my brain to see how I'm thinking about the problem. So now I've grouped 6 and 8 together. I'm going to solve that part first. So 6 times 8, I know makes 48. I can check my multiplication chart. I'm going to encourage you guys, the multiplication chart is a great tool. I would use it though to check your work more than to provide an answer. I want you guys to start really thinking about, even if it takes you a while and maybe you have to make equal groups, the more you practice those multiplication facts, the more they will be embedded in your memory. There are multiplication facts that I can pick out really quickly because I have done them so many times. You don't get the same practice if you're just looking at the chart. So the chart can be a great tool and it can help you double check your answers, but try to get to your multiplication first, doing it in your head or writing it down equal groups or repeated addition on a piece of paper or your whiteboard first before you double check on your multiplication chart. Okay, so we have 6 times 8. I am going to verify, yep, that's 48. So now I have 48, and I'm still going to multiply it by 10, right? So that's like saying I have 48 tens, or I'm going to think of it as 48 times 110. I'm going to add that 0 to the end to make it 480. So on the line where it says solution, you should have 480. Now again, you may have gone through the same steps and thought about the problem the same way that I did. That's cool. If you did, we're sharing the same brain wavelengths. If you didn't, that's totally fine too. You have a brain that works differently from mine, and that's equally as cool. So the nice thing about math is that all brain waves are totally valid ways of getting to the same answer. Now, if you didn't get to the same answer, that's okay too. You just want to go back and look at your steps and see which step maybe you missed, okay? All right, let's go ahead and look at number 9. Number 9 is a word problem, so we're going to go ahead and find the useful information by circling numbers, underlining the question, and boxing in keywords. So there are 40 nickels in a roll of nickels. Go ahead and circle 40. Tao has 7 rolls of nickels. Circle 7. How many nickels does she have in all? That's the question. And in all is going to be our keyword because it's telling us how many together or telling us that we're going to be multiplying, right? Or adding if we want to do the repeated addition route. But we don't. We want to go ahead and multiply because multiplication is fun. All right, so we have 40 nickels and we have 7 rolls. So we're multiplying 40 times 7, okay? So I'm going to go ahead and break apart 4. I'm going to do the same thing that I did. You can see that my brain is kind of stuck in this one track where it does the same thing. I'm going to break apart 40 into 4 times 10. And then I'm going to rewrite my problem, but I'm going to put my 4 and my 7 together because I want to save 10 for the last because that's the easiest step for me. So now I have 4 times 7, my 4 here, times my 7 here, and then times 10 here. I'm going to group my 4 and 7 together. So I know my 7 times 3 fact is something that I always come back to because for some reason that's just the one that I remember. I know 7 times 3 is 21. I'm going to add 7 more to that because instead of having 3 7s, I have 4 7s. So now I have 28. So 4 times 7 would be 28. I multiply that by 10. I'm going to say that's like 28 tens, add my 0 to the end, and it becomes 280. Now, on the solution line, because we're talking about something specific, we're going to write 280 nickels, because the question says, how many nickels does she have? It could have asked, how much money does she have? So we want to specify that she has 280 nickels, okay? All right, flying through these problems. Let's go ahead and take a look at number 10. Number 10 says we're going to multiply 7 times 30. Ooh, I like this one. I'm going to do my same technique of breaking apart 30 into 3 times 10. Because I like 7 times 3, so I'm going to rewrite it as 7 times 3 times 10. And I'm going to group these together because I know that one right off my head. I know that 7 times 3 is 21. If I multiply 21 times 10, I'm saying I have 21 tens, or 210. All right, and that one, because it's not asking for something specific, you can just go ahead and write in 210 on the solution line. All right, if you turn the page one more page, you get to 219 and 220. Those will be covered in our small group session on Tuesday the 15th. Turn one more page, pages 221 through 224 are there for extra practice if you need it. But before you go, we have some unfinished business to attend to. And that's something that's been bugging me all week. If I take us over here, you'll notice that I have one square left over right here that I still need to fill in for my 9s. And that makes me realize that I haven't yet taught you guys the tricks for 9s. So we haven't filled that in yet because we haven't had a chapter devoted on 9s. And there isn't a chapter devoted on 9s, oddly. I think that that's kind of an oversight because 9s have some really cool tricks that I want to share with you guys. So I'm going to go ahead and write up here. I'm going to start with 9 times 1. And I'm going to create a column of the answers right down here. And I want you to look carefully as I write them to see if you start noticing any patterns in the answers. So 9 times 1 is going to be 9. 9 times 2, we know that one already, that's double 9 or 18. 9 times 3, that would be like if I added these two and said I have 9 times 2, that's 18 plus one more group of 9, that's 18 plus 9, that's going to be 27. 9 times 4 is going to be double, so 18 2 times, that's going to be 36. 9 times 5, I can count by 5. 5, 10, 15, 20, 25, 30, 35, 40, 45. 9 times 6, I just happen to know is 54. I can also think of it as 9 times 3, 27 doubled. 9 times 7, I could think of that as my 9 times 3 plus my 9 times 4. That's going to equal 63. 9 times 8, oops, try that again, there we go. 9 times 8 is going to be like my double, so 36 doubled is going to get me 72. 9 times 9, we haven't gotten to yet, but we do know that 9 times 10 is 90. And I could find 9 times 9 by either adding on 9 to 72 or subtracting it from 90. I'm going to go ahead and add it to 72, so that's going to be 81. Now, I'm going to erase these. Because I just want to take a look at the products really quickly. And I'm going to do this. So, my products, I have 0 and 9, 1 and 8, 2 and 7, 3 and 6, 4 and 5, 5 and 4, 6 and 3, 7 and 2, 8 and 1, and 9 and 0. So you may have noticed, if you were looking for patterns, that the tens place is increasing by 1 each time, right? It's like counting by 1. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You may also have noticed that the ones place is counting backwards from 9. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So together, they count both forwards and backwards in each column. But wait, so that's the first mind blow. But wait, there are more mind-blowing parts of this. So I'm going to go ahead and rewrite in the expressions. 9 times 1, my 0 in my tens place is going to be 1 less than the number that I'm multiplying by. But both digits in my answer, I'm going to add together and they're always going to equal 9. Watch this. 0 plus 9 equals 9. Okay, admittedly, that was kind of anticlimactic, but watch the next one. 9 times 2, my ones place is 1 less than the number I'm multiplying by, and I'm going to add 1 plus 8 to get 9. Okay, 9 times 3, my tens place is 1 less than the number I'm multiplying by, my other factor, and 2 plus 7 equals 9. Right, 9 times 4, tens place is 1 less than 4. I'm going to have 3 plus 6 equals 9. 9 times 5, tens place is 1 less. 4 plus 5 equals 9. 9 times 6, tens place is 1 less than my factor that I'm multiplying by. I have 5 plus 4 also equals 9. And you may have noticed that now I'm going backwards, right? I had 4 and 5, and now I have 5 and 4. Next, I'm going to have 6 and 3. That's backwards of 3 and 6. So I have 9 times 7. 6 is 1 less than the 7, but I still have 6 plus 3, making 9. Let me erase these because these seem superfluous. Ooh, superfluous. Great vocabulary word. If you don't know what it means, look it up. S-U-P, in fact, I'll write it up. Superfluous. Superfluous. Look it up and type in the chat for this video if you found what it means. All right, 9 times 7, 9 times 8. Tens, 1 less than 8. 7 plus 2 equals 9. 9 times 9, tens place is 1 less. 8 plus 1 equals 9. And 9 times 10, tens place is 1 less than my other factor, and 9 plus 0 equals 9. Okay, so that's the second mind blow. The last mind blow I have for you is what I call the hand trick. Okay, so I'm going to leave these up here behind me, and I'm going to teach you the hand trick. So for the hand trick for nines, you're going to go ahead and hold, there we go, both hands out in front of you like this. So you'll notice that you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 fingers, right? You all have 10 fingers? Okay, good. Just checking, because otherwise it's not going to work for the nines trick if you don't have 10 fingers. Sorry. Okay, so for the hand trick, you're going to go ahead and let's say we want to multiply 9 times 3. So what I'm going to do is I'm going to go ahead and count over 2 fingers from the left. So I'm going to say I have 1, 2, oh, but I'm multiplying by 3. I'm sorry, I'm going to count over 3 fingers. So 1, 2, 3. I'm going to put down my third finger, and then all of my fingers on the left-hand side of my finger that's down are going to be my tens, and all of the fingers on the right-hand side are going to represent my ones. So I would have 2 tens, and 1, 2, 3, 4, 5, 6, 7 ones. So my answer would be 27. Can we double check it up here? Yep, 9 times 3 is 27. Let's try it with another one. Let's do a harder one. Let's say 9 times 5, okay? So I'm going to count from the left, from pinky on the left, say 1, 2, 3, 4, 5. Put my 5th finger down. All of my fingers on the left-hand side are going to be my tens place. All the fingers on the right are going to be my ones place. So I have 4 tens and 5 ones. My answer would be 45. And if we double check that, 9 times 5 indeed is 45. Let's do it one more time. 9 times 8. Okay, so I'm going to count over 8 fingers. 1, 2, 3, 4, 5. Keep going on the next hand. 6, 7, 8. I'm going to put that finger down. That's kind of hard. All of my fingers on the left-hand side of my finger that's down are going to be my tens. The 2 fingers on the right-hand side are going to be my ones. So I have 1, 2, 3, 4, 5, 6, 7 tens. One of them really dirty from wiping off the whiteboard with my finger. Don't do that. Use your eraser. And then my 2 on my right side are going to be my ones. So I have 7 tens and 2 ones. That would be 72. 9 times 8 we see is 72. I just totally blew your minds, right? So those are the nines tricks, and they're great ways to not only help you memorize your nines, but also for you to double check your work. So always make sure that your 2 digits that you multiply by 9 are going to add up to 9, right? You can also use the nifty hand trick. Some bad news, the disclaimer on this, it only works with up to 10. So if you want to multiply 9 times 11, you don't have 11 fingers, hopefully, and you can't do it. The trick kind of peters out at 9 times 10. But the good news is, by the time you get to 11s and 12s, the tricks are pretty easy and you don't need to worry so much about it. So let's go ahead and ceremoniously fill in the last one. So we have 72. So 9 times 9, I'm going to have 1 less than the number I'm multiplying by 9 in the tens place. That would be 8. I would think of what number I would add to 8 to get to 9. That would be 1. 8 plus 1 would be 9. So 81 is going to be what we put in that final square. All right. I hope you guys have enjoyed some working with the distributive property of multiplication, also our handy nines tricks, and I will see you guys next time, hopefully with that expanded vocabulary of what superfluous means, and I'll see you on Tuesday to practice some math. All right, bye.